Let's go, okay? The circle is now present with us, not missing, not forgotten. Now the circle, quite simply, as I told you, we will take this circle. So now, for me, I will start to hold the circle up close like this, all right? Because the circle here has a mistake or something that should be done, so I did it here like this and wanted to explain it, all right? Okay. The matter is quite simply that this circle has three parts. The first part that you see here, here you have what is called K0. All right, this is called a K0. The K0 is not forgotten. It's what I'm telling you about, which is the coil or the solenoid or the lock that is there, so you can't move your lever from the H position to the free position. Is that clear? Very good. So how does this lever work here? Quite simply, you have something here called a case relay, and here you have something else. First, this comes from another panel. If you go to another panel, you will discover that this is the bus riser panel that contains the bus bar air switch head to toe. So here, you must ensure that the bus bar air switch is open to allow the DC to pass to this solenoid so that it permits you to move the lever from what, to what, to what. All right, great. I will definitely explain 3 to you, but I'm just waiting for one moment. Okay, so who are LS9 and LS10? Well, LS9 and LS10 are simply limit switches. You have a limit switch here called LS10, and here you have another limit switch called LS9. So one is in this position right here. Sorry. One is in this position called LS10, and one is in this position called LS9. Great. So what is their purpose? Let's see what their purpose is. What is written about them in the drawing? It tells me here. It says here that LS9 and LS10 are what? It tells you that LS9 is activated upon lifting the lever at each position. So LS9 is, I drew them for you the other way around, meaning LS9 is located here. LS9 is the one located here in this position. Regardless, they are all the same, meaning here there is something called LS9, all right? And here there is something called LS10. I have them here and here. These are two limit switches which are called end of stroke switches. One is located here, and where is the other one? It's located in this position. What are they called? Limit switches, which are end of stroke switches. Great, guys, nice before. The idea is quite simple. What is the idea? Simply put, LS9 and LS10 are in a closed position when or how they are activated. It says that LS9 is activated upon lifting the operating lever at each position to energize K1 to be able to move the lever to the F position. And LS10 is activated when the operating lever is at the F position. What does this mean? It means quite simply when you hold this black lever, you just lift it up like that. When it is in the H position, you lift it up. And as soon as you lift it up, LS9 becomes closed like this. As you are holding it, it remains closed in this manner, okay? And LS10 is closed. As soon as you move to the team position, LS10 then opens. Okay, and if you are free, as soon as you move away from the free position, you will find that LS10 has returned to being closed. LS10 has returned to being closed, exactly. As soon as you reach the H position and move down, or when you move down, in the H position, you will find that LS9 is the one that opens. What does this mean? LS9 and LS10, in short, want to ensure that when you move the lever from H to F, they allow DC to pass to K0, which is related to the mechanism that will move away to allow you to move the lever from H to F, right? If you leave it set on the H position or the on or on the F position, both of these must be open. If you are on the F position, LS10 is normally open. And if you are on the H position, LS9 is normally open. Why? Because this mechanism, similarly, its coil draws a high current, so it might move. What does it do? It ensures that the DC does not continue on the solenoid by placing two limit switches, two normally open switches. One here, in this place here above, and the other one is present here. Is that clear? So it ensures that if you are at the F position, one of them is open, which is LS10. And if you come to the H position, one of them is open, which is LS9, right? That's why it ensures that if you are standing at H or standing at F, in these two places, there is no current or voltage reaching the solenoid that allows you to move the lever from H to F so it doesn't burn out. That's it. This is the concept of the limit switch. So this is a mechanical feature in the switch generation. There are no issues. Here, you must ensure that the passport sends a switch open command, because as we agreed, as long as the passport sends a closed switch command, if I return the lever to position F and start to insert a breaker, the breaker might stop and a short circuit could occur. So what does it do? It prevents the lever from returning from H to F, unless the passport sends a switch open command. Engineer Rashad, are you trying to tell me that what does this mechanism do? Focus with me. The sole function of this mechanism, or this solenoid, or this magnet that is present, is to prevent, as you can see here, it prevents, as I explained a little while ago, it prevents the movement of the lever from H to F only. It prevents its movement from H to F, meaning it is in the hold position to the free position, which allows you to do a rack in and rack out. This applies here in the Weimar, in ABB, in Schneider, or in any other brand. The same idea applies. It prevents the mechanical movement of the breaker when you have it racked in. So this is the general term. It prevents the mechanical movement of the breaker when you rack it in. How is it implemented? It depends on how each manufacturer implements it. Weimar told you what to do. You put the lever in the H position, right? I said yes. He told me you will never put it in the F position because your intention is to rack it in, right? Am I wrong? I said yes. He told me you will never put it in the F position, which allows you to rack in the breaker, unless the bus bar air switch was open. All right then? Very good. So far, everything is fine. I will proceed as if I don't have anything called a capacitor bank, okay? Very good. So what is this? This is my branch, okay? So this is the first branch, right? This is my first branch, okay? Engineers, all right? So this is the first branch. AK3, forget about it. I will talk as if it's a regular feeder or whatever, okay? Very good. So the regular feeder only looks at the bus bar air switch, and here you have the two. All right, I want to close the bus bar air switch. What should I do? Focus with me. To close the bus bar air switch, I need to make sure that the breaker is racked out. But not only that, it should also be on hold mode. Why? Because if I leave it racked out and it's in free mode and I go to close the air switch, it might rack in the breaker. But when I set it to hold mode and close the air switch, the air switch will prevent it from returning from H to F. How? Through my solenoid. That's why, what does it do? It uses limit switch 8 here, which is activated, meaning it works with you when the vacuum circuit breaker is in the test position and the operating lever is at the edge position. All right, how does it perform this loop? It performs the loop like this. Let me bring the other camera. It makes its loop like this. So you have the cell, for example, this is the bus riser cell that contains the earth switch. This is the bus riser cell. Is that clear? Great. This cell contains a DC circuit with positive and negative of this cell, which is the bus riser that contains the bus bar earth switch. What does the bus bar earth switch do? It takes this positive and connects it to the cell next to it, right? And the cell next to it and the cell next to it, for example, we choose among 3 cells. It comes here to the cell and takes the LS8 position. And then it exits this cell and goes to the next cell, LS8. And then it exits these cells to the next cells, takes LS8, make sure that the breaker is rack out, and hold rack out and hold, because you can never put it on hold unless the breaker is rack out, all right? And then it returns with this end here, all right, up to there, all right? It has a circuit. And at the end, this circuit reaches negative, which means if this breaker is in the rack out position, and this breaker is in the rack out position, and this breaker is in the rack out position, then at that time the positive will go. And it returns to me again to activate a specific interlock circuit so that I can close the bus bar earthing switch. Is that clear? So here it has drawn this circuit for you, something like this. You have this branch in your pre. It told you that this comes from the cell before you and goes to the next cell. Count here, what did it take from you? It took from me. They are all connected because they all need to be closed. So what does that mean for the breaker? The breaker total breakout, all of it is a breaker total breakout, and it set the whole position. Is that clear? Engineers? Very good. Up to this point, this is how any feeder would be discussed, and you have no problem at all. Very good. Now let's see if I have a capacitor bank, what gets added. Let's understand this capacitor bank, engineer, very simply. You have in the station that I talked about, this video is supposed to expand on the capacitor bank, right? Am I wrong or right? Okay, this capacitor bank is located outside the station. There is a space like this, and in this space, there is a set of capacitor banks arranged in this manner. We see them in many places. Let me even show you one right now. For example, a capacitor bank. I will also send you a picture of it. It looks like this, not forgetting what it is. These are its images. Anything from outside the station looks like this, like the shape you see here. Or, for example, up close, you will see this view. Here is a view like this, for example, in power stations. This is what the capacitor bank looks like that we have in power stations. The capacitor bank itself is not important to me. What matters to me is that this capacitor bank is located in a yard, an area outside the station, and this entire area is surrounded by a fence. The fence is like a wall, and this wall is made of iron. There is a gate here, which we call the fence gate. What do we call it? All right. Someone is sending me a message here. Yes, a security mesh. Exactly like a security mesh. Let me even show you. So if anyone wants to imagine it, you have the picture here. Here is the outer gate, or let's see a closer picture, or let's write it here like this. Yes, between the gate, the fence, gate, it's like a gift, not an engineer, of course, but it's big, and you have a gate. Yes, a gate for it. So we call this the fence gate, which is the mesh gate. So you can enter the capacitor area. Everything is, of course, surrounded because this place is not supposed to be approached since it's full of electrical charges. You can't get close to it. So it's naturally surrounded by a wall at a safe distance, and it has a gate to enter this area. All right, very good. Now this gate has a key, and here we start with the second story. Now I have understood the mechanical interlock between the breaker and the earthing switch. We got it right. Okay? We agreed that for me, focus now, this story is settled. I agreed that for me, based on these keys, if I switch from position A to B, then I won't stop at a breaker rack-in. And if it is rack-in, I wouldn't stop switching it from A to B. And the same applies to F and H. You even saw with me when I switched to position H, I found the same lock that comes out and prevents the breaker from its RAKN movement, or the breaker achieves RAKN as a result of moving the pulse. This is position B. You saw both are the same. Whether you switch this to position H or from A to B, this tongue comes out to prevent the breaker RAKN. And if the breaker RAKN wasn't tired, it wouldn't perform this movement, nor would you be able to switch it from freehold or from A to B. All right, so we saw this mechanical interlock, and we said, if I want an electrical interlock, how would I do it? We agreed that if the hold position is taken with a button to move your lever from hold to free, it can only be done when this lever or this solenoid or this button is picked up or removed. And to remove it, you must ensure that the bus bar sends a switch with it open. Okay, and regarding the interlock between me and the bus bar switch, the breaker must be racked or placed in the hold position. So we finished this topic and everything is fine. There are no problems at all. Now we are talking about the capacitor bank. As I told you, here is the gate and here is the group of capacitors, for example, located here. Great, very good. So I have engineer right now, a gate here in this place. As I told you, we will call this the fence, a gate, which is our fence gate. You told me it's nice. Okay?